So bear with me for a couple more minutes before lunch. I think my job is very difficult here. So this is ribosome. I'm inspired by this little beast that operating in our bodies like every single second and building so many things that is making us alive. And by getting inspired by this machine, I would like to build some synthetic molecular machines. And obviously, this is not the only time or the first time that we have been thinking about this. There are pioneers before us who enabled single molecule nanopore sequencing, particularly enabled by the enzyme called helicase. Here, what you observe is a helicase is pulling out the DNA molecule and then going through a single molecule through a single nanopore cavity. And by doing so, that you're basically, if you pass a current through this single channel here, that you're able to analyze individual current traces and delineate the individual sequences of the nucleobases. But obviously, this is a very cool technology. Now it's commercial and such, but there is no enzyme that for protein translocation or sugar translocation, as a matter of fact. So the idea here right now that we are investigating as an alternative is why not using chemical translocation of biopolymers, and by specifically applying a very reactive chemistry using the selenium compounds here, as you can see. So basically, within this nanopore cavity that we put basically an array of like thiols and the cysteine molecules that can go up and down through directional movement of a net charge on the molecule. Basically, this approach is quite versatile because we can basically say that this is going to happen based on its charge, and it can be also reversed by using the opposite direction of the voltage so that we can rerun these molecules up and down. And here what you observe is a real-time, this is my video, I know it's just not the best one perhaps, but a real-time single molecule is happening, a chemical reaction is happening as you can depict here. I am still fascinated by how much this technique is basically giving me resolution at a millisecond or microsecond level, if you're lucky on a day. And if you're interested in this type of chemistry and further other applications that we are trying to figure out right now, please stop by my poster, which is, I guess, now number 44. I'm happy to chat with you. Thank you very much.
Thank you.